Hello everyone. So today this is just part of it's a series of all the chapters mainly geared towards 10th standard students. So I'm going over the important concepts, all the concepts. When I say important, all the concepts in that particular chapter. So we'll go over all those concepts so you can apply these concepts in solving any of the problems related to them. So today the chapter is polynomials. This chapter is mainly geared towards 10th standard students. You can watch this video again and again, and please share this video with your friends too. So my name is Mariraju Dapur. I'm an author and a coach. You can learn more about me from mathsformula1.com. So now let's get started. So polynomials, we started off, when you started off learning even from previous standards, you started off with expressions or algebraic expressions. The reason why I'm saying this is the concept where you might even look at certain questions where you have to differentiate between the given expression is a polynomial or not. So we'll just understand the definition of polynomial and then some examples so that you can differentiate and then try to pick the right type of polynomial. So expression, so when you had an expression, it had a variable, constant, and a coefficient. Right. So now if I write an example, so we all had all different types of 2x plus 5, 3x square minus 2x minus 4, all types of expressions. But during that time we also learned a monomial, binomial, trinomial, and so on, trinomial or polynomial. These were all based on number of terms used. So remember that. So monomial actually had only one term. Here there are two terms. So understand the basic concept. These are terms, right? These are all called terms. So this had only one term, two terms, three terms, or otherwise anything more than two terms. All of them are polynomials. So we have this as a polynomial, right? So now let's just take the same example, 3x square minus 2x minus 4. This is my constant. Constant is the one where we can't change the value. Variable, the value varies, that is a variable, x is a variable. These are numerical coefficients. So then after that you should be able to differentiate these things in terms of terms, and then also try to look at the polynomial and try to figure out the degree of the polynomial. So if I look at these terms, there are three terms. The highest degree of the term, so as you can see, this is the term which has the highest degree. Let's say exponent, that is my exponent, this is the base. So if I look at that, that's the highest degree. If I look at this, there is 1, nothing is there, that is x to the power 1. So that way if you see, the degree of this polynomial is 2. Degree of that polynomial is 2 because the highest degree of one of the terms is 2. So if I had 3x cube minus 5, although there are two other terms are not there which are in the decreasing order, if I were to write this in decreasing order, 3x cube minus 0x square plus 0x square plus 0x minus 5. These are the ones which are missing because my constant, if I actually rewrite that in the decreasing order of those exponents, that's my entire polynomial. But these are the two which are used because these two they don't occur. they don't exist. So now if you look at this, that's the highest, so degree is 3. So remember that degree, based on that you can actually differentiate between polynomial. So now let's come back to some of the examples of just the polynomials itself. So if I take a function or in a polynomial which is 3x square minus 2x plus 5, I can call this as a polynomial in variable x. Polynomial in variable x. That's where x is, and these are all variable x. So in the sense, if I am actually going to substitute some value to this, then I am going to substitute value of that. So the value of that polynomial at x equals to 5 is actually going to be whatever we substitute and find it out. So that's the value we get. Now if you look at this, let's just go a little bit further. Like I said, this is constant. This power, these two powers are positive integers. Remember, that's how you will be able to differentiate positive integers. And then these are constants. So these are constants, but coefficients of those particular variables, but constants. So but as you can see, these constants are real numbers. We already know what are real numbers. So real numbers, I can actually have a rational or irrational number, such as root 3 x square minus root 2x plus 5. That's fine. So it's still a polynomial. But as you can see, I had mentioned the powers or these exponents are positive integers. These are real numbers, and this is variable. These three things you need to remember when you are actually differentiating polynomials. Now let's try to look at one or two examples for which I can't call them as a polynomial. 2x square minus 3 root x. If you know exponents, root x can also be written as x to the power 1 by 2. It's not exactly just the positive, it's a fraction, but it's not straight away positive integer, so I can't call this as a polynomial. I cannot even call something like this as a polynomial, 1 over x square minus 2x. We won't get any of these values to differentiate, to define that as a polynomial. Or otherwise 2x cube minus, I don't know, 6 by x plus 5. That's fine, but if I write this in terms of powers again, when it comes up, 1 divided by x to the power 1 is written as x to the power minus 1. It's not a positive integer. It's not a positive integer. So in all these cases, I can say that safely, I can safely say that they are actually not polynomials. So now let's continue with the types of polynomials. First, we'll start with constant polynomial. Constant polynomial. Constant polynomial is the one which has degree 0. Degree 0. So if I had x cube minus x square plus x minus 1, degree is 3. Similarly, x square plus x minus 1, degree is 2. X minus 1, degree 1, just minus 1, degree 0. So that means I'll be left with a constant, so that's why it is a constant polynomial. Then linear polynomial. You must have even gone through or learned linear equations. So what was the main idea behind linear equation? Linear equation, or in this case linear polynomial, is degree 1. Degree 1. Linear, so degree 1, linear, so linear equations like whatever you have learnt in one variable or two variable, but in all the cases the degree was 1. 2x plus 5, 3y minus 2. Linear equation is one variable, 2x minus 3y. Linear equation in two variables, but the power degree is still 1. So remember that. Then the one with degree 2 is called as quadratic polynomial. The one with degree 3 is called as cubic polynomial, and then one with degree 4 is called as biquadratic. So these are the ones you need to remember. Sometimes you might have to differentiate. First of all, sometimes you might have to see whether you can actually find the polynomial itself, and in some cases you need to differentiate the type of polynomial. Now let's look at value of a polynomial. Value of a polynomial, right? So this, we know this actually even from previous standards, but let's just understand this. How do we substitute and what do we call as value of polynomial? Because from value of polynomial only then we can go to 0 of a polynomial. What does it mean by? So let's understand all these things, but you have to keep in mind, even though it's polynomial, you need to understand a good concept of factorization. Factorization is a must. The reason why I am saying this is, if I am actually going to take x square minus 4, I can factorize this into x square minus 2 square, which is a square minus b square. So that means x plus 2 into x minus 2. This you have learnt in previous standards. So these are the two factors, right? So the reason why I'm mentioning factors, will get to that, but the reason behind why I'm mentioning this is that you need to know factorization, or otherwise you need to know the concept of factorization, how it works. Mainly it's not only about factorizing something, but also in terms of understanding what is factorization. So value of a polynomial. Let's take a variable alpha, which is a real number, and let's take a polynomial as well, which is 2x square minus 5x plus 1. So that's a polynomial, that's a real number. So if I'm actually going to substitute that particular value in that, so that means I'm actually going to call this as value of f of x at x equals to alpha. Value of this polynomial at x equals to for the given number, So let's take an example. That's a better way to put it. So if I'm going to take alpha as 5, so what is the value of that polynomial at x equals to 5 is, I'm going to substitute all those values here. The correct way of writing that is f of 5 is equals to 2 5 square minus 5 into 5 plus 1. So whatever value you get is the value of that polynomial, but what do we know? This polynomial in variable x. So that means if I am going to take the value of that polynomial at x equals to 5, I'll substitute the x value in my polynomial and find the final value. So that's the value of that polynomial at x equals to 5, whatever value it's given. So let's come back to that. Now what happens if I put that value? I'm not going to get 0 here. There are instances where you can find 0, but that's the reason I'm going to mention about that now. So here you might not get 0, so whatever, it might even be negative as well. So now if I want, what if I have a value for x wherein this polynomial is actually going to give me 0? So that is called 0 of a polynomial. Zero of a polynomial. Let's take f of x equals to, I'll use this x square minus 4. So x square minus 4. As I know, f of 2, if I take, that will be 2 square minus 4, which is equals to 4 minus 4, that's equals to 0. So that means, what does it mean? If I'm going to substitute that here, this is actually going to equate that to 0. So that particular value 2 is the 0 of this polynomial. So if I'm going to represent this in terms of just variables, f of x is equals to ax plus b. Let's just take only one, degree 1. That's a simple one. So if I take that expression, if I take that particular polynomial, then for the value, whatever value if I'm going to put instead of x, if I'm going to put alpha, this actually has to be 0, because if I treat that alpha is actually going to give me 0 for that polynomial. So that means ax plus b, sorry, it's not ax. Now instead of ax, it should be a alpha plus b is equals to 0. So alpha will be equals to, if I transpose it that side, that will be minus b, and if I transpose this a, that will be a. As you can see, this was the one which we took as 0 of the polynomial, which is, if you look at it, let me explain that. Let's come back here. You don't want to get confused. These two are factors, but they are also 0 of that particular polynomial. How? Let's just take x plus 2 is equals to 0, x equals to minus 2, other one is going to give me x equals to plus 2. If I substitute here, minus 2 will give me 4 minus 4, plus 2 will also give me 4 minus 4. So that means I'm actually going to get 0. So these are actually factors, but also zeros. If I am actually going to use that as equals to 0 and find the value of x, then that particular value is the 0 of that polynomial. So if I come back to this, that alpha is 0. That's what we actually took it, 0 of that polynomial. But on the right hand side, that's a 0 which you can obtain by factorizing. On the right hand side, what I have is coefficients. So minus b was here, this was a constant, and this is a coefficient. So minus b, that was a constant, divided by coefficient of x. As you can see, we mentioned that in terms of b and a, constant and the coefficient. So let's try to look at how we can represent, before we look into relationship between these particular coefficients and the zeros. Let's look at some of the basic things that you need to know in terms of graphs. If I'm actually going to draw a graph, geometrical representation of a polynomial, how is it actually going to look like? Graphs of polynomial. So graphical representation. Let me just draw, because sometimes you might get questions based on recognizing particular graph, what type of polynomial is it. So let's look at this. First, if you remember, linear equations are now linear polynomial. It's a linear polynomial, one variable. Your graphs for each equation, it's actually going to be a straight line. So if I'm actually going to use linear polynomial, my graph, whatever I'm going to take, linear polynomial 2x minus 5, degree 1. So that will be my 2x. I'm just representing this. It might not be exactly lie on the graph, but if I take that, that's what is actually going to happen. It's a straight line. So if I'm actually going to plot more than one, so there will be more than one line. So let's look at quadratic polynomial. Again, concentrate mainly on the representation. You will learn more about this in higher grades, but concentrate more on recognizing the type of graph. So now let's understand the graph itself. The graph for quadratic equation is actually going to look like a parabola. You will have a vertex here, and this parabola cuts or touches x-axis at 2 points. That's 1 point, that's 2 points. If you remember, in the previous page we used x square minus 4. That actually had x plus 2 and x minus 2. X square is a quadratic. It's a quadratic polynomial. So that means quadratic polynomial actually has 2 zeros. These are 2 zeros which are actually going to touch x at 2 points. One was x minus 2, another one is x plus 2. So I can actually treat this as plus 2 and minus 2. So as simple as that. So but also you need to keep in mind the sign of the highest degree, which is x square, for this quadratic polynomial is positive. So that's why this parabola opens upside. So that's only for now. That's the main concept you need to remember in recognizing a quadratic polynomial. So based on that, questions might be, so let's try another graph which is upside down. It is touching or cutting x-axis at 2 points, so automatically it's a quadratic polynomial. It goes down, it opens down, so that means the sign of that particular degree is actually going to be negative. So this can be something like minus x square plus 4. Sign is negative, parabola opens down, there are 2 points, it's a quadratic polynomial. It has 2 values, 2 zeros, right? So similarly, there are other one more graph. So let's just take that part. There is only one which is touching x-axis. So here examples: x square minus 4x plus 4. I think this should be x minus 2 and x minus 2. X square minus 2x minus 2x plus 4. Yeah. So if you look at it, it is x minus 2 whole square, but these two are my factors. Those two are zeros, so that means x equals to 2, and another one is also x equals to 2. So what do we know from this? This has equal values. So when you have equal values, you can actually have two values touching on x-axis at only 1 point, but it's opening up upwards, so this is positive. If the same thing opens downwards, that might be negative. This will be negative. But only thing is, it might have two equal values, equal zeros. So those are the things you need to remember. One more thing is cubic polynomial. So something like that. That's a cubic polynomial. 1 point, second point, it's cutting x-axis at 3 points. X cube minus, what I can do is x cube minus 4. Let's just take 4x. Let's just take 4x. Yeah, x cube minus 4x. So as we know, linear equation, we had only one solution. Even if I wanted to find out here, this will be x equals to, if I take it as 0, or otherwise if I rewrite it by transposing all this, it will be 5 by 2. Then when I took quadratic polynomial, so I had two of them here, both of them different, and both of them are actually touching x-axis or cutting x-axis at 2 points. And for this particular cubic, it's a sample example, so you just need to recognize there are 3, it's touching at 3, or that particular curve is touching at or cutting x-axis at 3 points. So that means I need to have 3 values here. If I take x common, that will be x square minus 4. X square minus 4, I can write it as x plus 2 and x minus 2. 1, 2, 3. 3 values. Cubic polynomial 3 values, and quadratic polynomial 2 values. So similarly, without saying it goes, if I am going to go with biquadratic, it will have 4 values. Biquadratic will have 4 values. So the main thing to understand from this is the type of graph, how to recognize, and I've also explained with a little bit of examples where how to recognize certain graphs. One more thing I forgot. I'll just try to write somewhere here itself. Let's take another graph. That graph, parabola opens upside, so that means my what is that, x square is the highest degree, can be positive, it is positive, then minus 7x plus 5, I think so. This should be 5, 1. So this one is not factorizable. When I say not factorizable, I am not able to find, I will not be able to find two factors. I guess I've just taken this as an example. Let's just take 5 ones. No, it's not possible. So I'll not be able to find factors for them. So that's the reason this, because I can't find the factors for this particular parabola is not going to cut or touch x-axis. So might be a quadratic equation, but it is not factorizable. Remember this. So that's where you need to differentiate between not only the type of equation and what is the scenario behind representing that particular graph if it is not touching x-axis. So similarly, same thing goes with the one which opens down. It is not factorizable, but the sign of that particular quadratic equation highest degree, or that exponent, that particular term, is negative. In the previous pages, what we looked at polynomials based on different degrees. So here we'll try to find out the relationship between the zeros and coefficients. I have also mentioned already, mentioned specifically which ones are the coefficients and the zeros. Let's just take some examples and then try to show those relationships. So if I'm going to take ax plus b, a polynomial in degree 1 equals to 0, and if I substitute x as alpha, and that will be a alpha plus b equals to 0, alpha will be equals to minus b by a. So the value of that particular alpha is actually going to be in terms of coefficient. So when I say x equals to alpha, that is that is the 0 of that polynomial. 0 of that polynomial. So in the sense, if I am going to represent a number for alpha, and if I substitute here, LHS is actually going to give me equals to RHS, or otherwise if I don't consider equals to 0, that polynomial is actually going to give me 0. But if I take that 0, in this scenario it's only 1 0, because degree 1, that in terms of coefficients, minus b by a is my constant, and that's a coefficient. So minus b by a, it's based on the coefficients from the polynomial. So let's look at quadratic polynomial. What happens? Remember, we actually looked at one of the questions examples, x square minus minus 4x plus 4. So this will be x minus 2 and x minus 2. That will be x square minus 2x plus 4. Yeah, that makes sense. So how do I get this? By factorizing. Factorizing, you get that. So what are these two? These two are my factors. These two are my factors. So what are the zeros of this quadratic polynomial? X minus 2 and x minus 2. If I equate that to 0, I'm going to get the values of x equals to 2. In this scenario, both of them are same, so I can take 2, or in some scenarios you might have 2 and 3 or 3 or 5 and 7, so it doesn't matter. But main thing is you will have two factors and two zeros here. So that means if I am actually going to substitute that 2 in this is actually going to give me 0. That's why we call this as 0 of the polynomial. So now let's see, if I take this as 0, x equals to 2, in some cases they might be different. How do I represent them in terms of the coefficients, what we did here? So what we'll do is I'll just take an example, which is let's take f of x, a polynomial, quadratic polynomial, ax square plus bx plus c. Let's assume if I factorize this, I'm actually going to get x minus alpha and x minus beta as two factors. But how did I write this? If I'm going to take x equals to alpha and x equals to beta as two zeros, and if I transpose this, I'm going to get x minus alpha here, x minus beta. So you need to know that exactly. When I write x minus alpha, x minus beta, it doesn't come just like that. If I take x equals to 2 here, the factor is actually going to be x minus 2 if I transpose it that way. So these are the two factors. So let's take these two and multiply this. So what do you mean by factors? If I'm actually going to multiply these two, this and this, let me just change the color. When I say factors, these two, if I multiply these two, I need to get that polynomial back. So that means my ax square plus bx plus c should be equals to the product of my factors, x minus beta. I'll add k as a constant. K as a constant. This constant can be anything. It might be 1, it'll not be 0. It might be 1 or it might be a different number. Constant. So k as a constant which can take up any number as in terms of for that particular place. So if I'm going to multiply that, x into x, x square, then x into minus beta x minus alpha x minus into minus plus alpha beta, k x square. If I take out minus x, it will be alpha plus beta, then alpha beta. So if I multiply this k with all of them, I can actually leave it like that, but well, what we'll try to do is we'll try to compare that with the LHS. So that way I'll have to multiply that with the constant kx alpha plus beta plus k alpha beta. So that's what we have. So now if I compare that with what I have, what do I get? A equals to k, b equals to minus k alpha plus beta, c equals to k alpha beta. So now a equals to k. If I want alpha plus beta, a equals to k, straight away it's just a constant. Alpha plus beta, because we are concerned with alpha and beta because we have taken those two as zeros. Alpha plus beta will be equals to, if I take minus on that side, that will be minus b divided by k, but k is a, as you can see k is a, so that becomes minus b by a. And then similarly C equals to K alpha beta. Alpha beta will be equals to C by K. K is A, so automatically this becomes C by A. So as you can see, the relationship between my zeros, that and the coefficients, that is the relationship. In this scenario, the relationship is of a product and relationship of the sum of two zeros of this particular quadratic polynomial is equals to minus b. Minus b is the coefficient of x divided by coefficient of x square, and here constant term divided by coefficient of x square. So if you see that these two are relationships between the coefficients a, b, c and the zeros alpha and beta. So if the question is about find out or what is the relationship between the zeros and coefficients, you don't have to derive all this. I have just derived it in such a way that so you can understand, but this is what you need to remember. And remember, the main important thing is you can get product and sum. I can't get if I'm actually going to get alpha plus beta whole square, or otherwise if I need to find out alpha square plus beta square, I cannot straight away substitute the value of alpha plus beta, because this has to be, I have to use some identity. So in such a way that I will only be able to use alpha plus beta and alpha beta. We'll look into that. Some hints I will give you based on this, what you need to do for this type of questions. But remember, you'll be able to substitute alpha beta and alpha plus beta. Let's look at some of the scenarios of how we can use these zeros, sum of 0 and product of 0. Some value, maybe there is a polynomial here, polynomial given, and then you used it to find out sum of this, which is minus b by a, and this is c by a. How do I find out? Some scenarios we will see, so you get an idea exactly what to do with that. Alpha square plus beta square. I know that I can substitute these ones. There might be other ways actually you can do it, but this is the best way I think, in my opinion. So let's just try to find out how do we get this. If you remember in the previous standards, somewhere in algebraic expressions you have found out the value of x plus x square plus 1 by x square when x plus 1 by x is given, right? Or you have also found out the value of x to the power 4 plus 1 by x to the power 4 when the value of this is given. So during that time, all you have to do is just use identities. So when do I get, if I take this as a, b, or alpha beta itself, alpha square beta square, when I square two variables. So if I'm going to square a plus b, alpha plus beta square, a plus b whole square, a square plus b square plus 2ab, in this case alpha and beta, this is what I have. So as you can see, you can substitute this value, so that way if I rewrite this equation, alpha square plus beta square is equals to alpha plus beta whole square. If I transpose it that side, that will be minus 2 alpha beta. I can substitute product, I can substitute sum, so you got the value of this. So let's look at one more. What if it is alpha to the power 4 plus beta to the power 4? So what we'll do is, we found out this, there is no straight way of finding out this. So alpha square plus beta square whole square. Don't take just whole square. Don't take whole to the power 4. It's not going to help. You have an identity, but that is not going to help. The simplest way is, we found out alpha square plus beta square, square it again. So this is actually going to look like a plus b whole square, a square which is alpha square square, b square which is beta square square, plus 2ab, 2ab. Here a and b are alpha square and beta square. So what do I have from this? From the polynomial you have these two. From what we found out, we have alpha square plus beta square. I can substitute that here. I can substitute product here. Alpha square beta square, whatever I got, I can substitute that here. How can I rewrite alpha square beta square? Alpha beta whole square. If you remember exponents, I can put them in brackets. So then substitute alpha beta, you get the value. Then if you transpose it that side, you'll get the value of alpha square plus alpha to the power 4 plus beta to the power 4. So let's take one more. What if I need to find out, let's take entirely different. I can actually straight go away with alpha cube plus beta cube. Let's look at the identity which is involved with this. So what is the identity? Alpha plus beta whole cube equals to alpha cube plus beta cube plus 3 alpha beta into alpha plus beta, right? That's what we have. That's the identity. That's the identity we have. So now if you keep that in mind, we need to find out that. So that means I can actually substitute alpha beta, I can substitute alpha plus beta, I can substitute alpha plus beta. If you transpose all of them, you can find out this. Simple. So what if the same thing was something like alpha cube plus 1 by beta cube? It doesn't have to be exactly same every time, right? So if I take it this way, take LCM, alpha cube plus beta cube, then it will be beta cube plus alpha cube, or alpha cube plus beta cube. Substitute this with this one, and this one can be rewritten as alpha beta whole cube. In that scenario, you can substitute alpha beta and try to find out the whole value. So now you got an idea exactly when a polynomial is given. When you write alpha sum and the product, you can also find out the other things, which are alpha square beta square, alpha to the power 4, beta to the power 4, and cube. These questions might be either in straight away in this manner, or otherwise somewhere they must have given in terms of fraction. But don't try to substitute straight away. Take LCM, find out what is there, which identity you need to use, then you should be able to substitute the rest of the values. Let's look at the relationship between the zeros and the coefficients of cubic polynomial. So we already know cubic polynomial, how to write with degree 3. So let's just take exactly like what I did in the previous page. I'm going to take that same example, but I'll not solve it, but let's just take the same thing. So f of x, ax cube plus bx square plus cx plus d. Here a, b, c and d are my coefficients, right? And if I treat alpha, beta, gamma, these are the zeros. If these are the zeros of that polynomial, when I say 3, there are 3 zeros because it's a cubic polynomial. So if these are the 3 zeros, I can represent this as in terms of k into x minus alpha into x minus beta product of and x minus gamma. Sorry, that one is gamma, right? If you multiply all this and compare that with ax cube plus bx square cx plus d, what do we get is sum alpha plus beta plus gamma is equals to minus b by a, alpha beta plus beta gamma plus gamma alpha is equals to c by a, and the product alpha beta gamma is equals to minus d by a. These are the coefficients, these are my zeros. Sum with 2 at a time, sum taken product of sums of 2 zeros at a time, and this is the product of all of them. So this is the relationship between the coefficients and the zeros for a cubic polynomial. So now Let's look at the division algorithm, right? Division algorithm. Same algorithm, even the same division algorithm you had in even real numbers. So even from 4th, 3rd standard, previous standards, we have done the same thing. So if I divide 5 by 2, I'm going to get, sorry, 2 2 is a 4 and then 1. Divisor, dividend, quotient, remainder. Algorithm says my dividend is equals to divisor into quotient plus my remainder. Exactly same goes with this as well. If I am going to take f of x as my polynomial, g of x as my divisor, quotient as q of x with the value x plus r of x is my remainder. So remainder can be either a polynomial depending on your divisor, or even the constant, or otherwise remainder is 0. So if remainder is 0, the given divisor is a factor. So when I say divisor factor, so if 4 divided by 2, 2 2 is a 4, I get 0. So that means that will be a multiple of this, or otherwise the factor of this is this. So 2 into 2 is 4. In the similar fashion, so if I get remainder 0, the divisor is a factor. This divisor is a factor of the given polynomial. So any polynomial, whenever they have given, so you need to know how to divide that. Let me just take some example and then divide it. What I'll do is 2x cube minus 4x minus 1 divided by x minus 1. I'll just take this so at least you get an idea if you have forgotten. So you get an idea exactly how to divide polynomials, because if the question says divide this and then verify this with the division algorithm, so you need to put all those values. F of x is this, g of x is this, q of x what we are going to get here, r of x we are going to get it as a remainder. If I put all those values, so f of x on the left hand side should be equals to the RHS. So here what we'll do is first term, which is 2x cube of my dividend divided by first term of the divisor, that will give me 2x square. So 2x square is my first term of my quotient, 2x square. Then you need to multiply that quotient first term with the divisor. So 2x square into x, 2x cube, plus into minus minus 2x square into 1, so it's minus 2x square. I'll write it here because I don't have 2x square here. X square is missing. If you want, you can actually put it as 0x square. X square is missing, so we'll take it as 0x square. So make sure when you either you can put that 0x square, or otherwise when you're subtracting, you have to make sure that term exists different. You have to only subtract like terms, because we are subtracting, sign is going to change. This gets cancelled, and then this will be plus 2x square as is, minus 4x minus 1. So again first term 2x square divided by first term of divisor. Every time dividend first term divided by first term of the divisor, that gets cancelled, I get 2x. So I'm going to write here plus 2x, that's with the sign. Always take with the signs here. Plus 2x x 2x square, plus into minus minus, that will be 2x into multiplied 1, that is 2x. Sign changes, subtraction, that gets cancelled. Minus 4 plus 2 is minus 2x minus 1. Now I am going to take that with minus 2x divided by x. X gets cancelled, so it's minus 2. So minus 2 into x is minus 2x, minus into minus plus, minus into minus plus 2 ones are 2. Sign changes, again minus, that gets cancelled, minus 1 minus 2 minus 3. That is my remainder, that's my quotient, that's my divisor, that's a dividend. So just use the same rule for normal division even to find out the factors. So this is the same idea you need to use to find factors, or mainly for either proving some questions based on division algorithm, or otherwise just in a simple manner the division of polynomials. Let's look at finding zeros of polynomials. So we have already discussed everything, so what we'll do is we'll take it up one level high. So what happens is, when we, for degree 1 we have already looked at, degree 2 which is a quadratic equation, we had 2 zeros, and cubic we have 3 zeros, and biquadratic 4 zeros. Quadratic you can actually use factorization. Cubic you have learnt in previous standard, so there are two different ways. One is that if you have 2x cube minus 3x square plus x plus 2, the one method which you had looked at is finding factors of this. So 1 and 2 you will take plus minus, try to substitute plus 1 in this. If you get 0, so that means x equals to 1, x equals to plus 1 is a 0 of that polynomial. So but if I want to find the factor, that will be x minus 1 is one of the factors of this particular polynomial. Then you divide that whole thing by x minus 1 to find out if this is 1. So totally 3 zeros, 3 factors, so I need to find out other 2 more factors. So that means what is going to happen is, when you divide this with this, you will get quotient as a quadratic equation and remainder as 0, because it's one of the zeros. So that means your remainder has to be 0. So then quadratic equation, if you factorize, you will get 2 more. 2 plus this given one is actually going to be 3 zeros. So biquadratic is the same thing. So your either cubic, if they had given straight away that this is one of x is 1 plus 1 is the factor, then use this method, divide that and find it. Or otherwise, let's go to biquadratic, and then I'll explain the same thing here as well by writing steps. So biquadratic, so what happens, I'm just going to take random example. Try not to divide this, because just a random example, you might not be able to divide and then find remainder as 0. Listen to me very carefully when I explain exactly what you need to do. So let's say 2x to the power 4 minus 3x cube plus 5x square minus 3x plus 5. For this biquadratic equation, let's say if they had given 2 zeros already, so which is root 2 and minus root 2. 2 zeros. It's a common question, but you can replace these numbers with anything. 1, 2, 5, 7, anything. It can be anything. But only thing is, understand the concept, how it is to be understood. So if these are 2 zeros, so that means x equals to root 2, x equals to minus root 2. If I find out factors, minus root 2, and this will be x plus root 2. Understand why it's actually written. If I multiply this, this is actually going to look like x a minus b into a plus b, a square minus b square, a square minus root 2 whole square is 2. That is because these two, they said these two are zeros, so that means this should be a factor of this given polynomial. If it is a factor of that given polynomial, when I divide this, when I divide this, I'll just write it so you understand exactly. I'm not going to divide this, but you need to understand this. When you divide this, 2x to the power 4 minus 3x cube, you'll get a quotient here, and after all that steps, you'll get a remainder. What is your remainder? Remainder is supposed to be 0, because they had given these two as zeros, and this one we found it as a factor. If I divide this with the for the given polynomial, I must get remainder 0, because it's a factor. So now we already had, there are 2 zeros given, 2 zeros, because it's a biquadratic, so I need to have 4 zeros. I need to find out 2 more zeros. My quotient is actually going to be a quadratic equation. If I factorize this, I get 2 more zeros. As simple as that. These 2 plus 2, 4 zeros. Done. So understand this method of exactly why this is done here and what this is taken as and what happens when we divide to get remainder 0, and then quotient is actually going to be a quadratic equation if you factorize 2 more zeros. So totally 4 zeros. They'll give 2 zeros, then you just have to find out 2 more zeros. So this is one of the ways that you can actually find out all the 4 zeros for a given biquadratic equation. Let's look at one more question. Sometimes it has appeared even in final exams, but I'll try to explain this. Concentrate on this. Let's see. If I'm actually going to take some polynomial. Let's take the same polynomial what we had taken. Some polynomial 2x to the power 4 minus 3x cubed plus 5x square minus x plus 1. Right? Here what I'm going to do is I'm going to introduce some variables. Let me just change the color so you get to see exactly what I'm writing. That is A, and I'll put this as B. I can actually put it as 2B or anything because it just serves as a constant for me apart from variable x. So this given polynomial is divisible by some other polynomial which is x square plus 2. All for the sake of examples. If you want to divide, you can divide, but in this scenario the thing which is given is a polynomial, and this polynomial is divisible by this other polynomial. So when I say divisible by, if I say 10 is divisible by 2, so that means my remainder is supposed to be 0. If this is divisible by 2, my understanding is my remainder is supposed to be equated to 0. You need to find out the value of a and b. This is a common question, but many of the students, they get confused, but just pay attention. Given polynomial, it's divisible by x square plus 2 in this scenario, just for the sake of example, and then remainder is supposed to be 0 because it's divisible by that. You need to find out the value of a and b. So let's just say, because they have given that as it is divisible by x square plus 2, and I'm actually going to put 2x to the power 4 all that here, and I'll find out quotient here. I'm not worried about quotient because what happens in your quotient, you will not get those a and b. So what is going to happen is most of the time you will, in your remainder, you might get anything, but I'll just give an example. What are the things that you might get? How do you find out the values of a and b? X into a plus 2, sorry, a plus 2 and then plus b plus 3, right? That's my remainder. You need to find out, remember, you need to find out values of a and b, but according to the condition given, my remainder is supposed to be 0. So that means I'm actually going to substitute this to 0. B plus 3 equals to 0. This is whole constant. I will take it as whole constant, but this is attached with x. I'll keep it separate. I can substitute straight away to 0, but let me explain how this can be substituted to 0. Why am I substituting it to 0? X a plus 2 plus b plus 3 as a constant. I can write it as 0 into x plus 0. Value didn't change, it still remains the same. Then I can compare this one to this one to this. So that means my x a plus 2 is equals to b is going to be 0, and then b plus 3 is equals to 0. This x 0 by x, that gets 0, that means a plus 2 equals to 0, or a equals to minus 2, or b plus 3 equals to 0, b equals to minus 3. So that will be the value of a and b. So most of the time this is what is going to happen to find out the values. Something is given, some other value is a factor or otherwise divisible by some other polynomial, divide that, get the remainder, equate that to 0, equate each part of them to 0. Sometimes you might find, but very rare situation, because here is x square, so that will be x. If you find somewhere, let's say x and then x square and then some other value and then some constant, during that time this again gets equated to 0, that x square gets cancelled, whatever a alpha value, any value is given, so you should be able to find out. Here main thing to understand is remainder is 0. When you divide you get some remainder, you have to work on this division here, pay attention to what gets cancelled, what doesn't get cancelled, then equate that to 0. How to substitute 0 I have explained here, substitute them and find the values. So with this I think I've covered all the concepts needed for this polynomials chapter. I'll be continuing with the next chapters. If you have any queries, doubts, or otherwise any chapter that you want me to do it first, I'm going from second, third, fourth chapter. I didn't start with real numbers. So if you have any request that you want me to do something before, just let me know in the comments. And if you are wondering about trigonometry, there are some videos on my channel, so you can actually watch them, good videos based on angles and then just the basic concept of trigonometry. So I hope you got something out of it. If you don't understand for the first time, try to watch it again and again. If not, then you can actually leave me some comment, then I'll try to answer them. Okay, thank you.